Hello class, let's learn about atoms, elements and periodic table through problems. An atom has 48 electrons, 72 neutrons and 50 protons. Before we do these questions, let's look at what are protons, neutrons and electrons. So you have to remember that protons and neutrons are located in the nucleus and electrons are located outside of the nucleus. Protons have +1 charge and 1 atomic mass unit of mass. Neutrons have 0 charge and 1 atomic mass unit of mass. Electrons have -1 charge and the mass is negligible. Atomic number is the number of protons. Mass number equals to the sum of your number of protons and number of neutrons. Isotopes are the atoms that are of the same element, however have different masses. So let's go to this question. What is the atomic number? Now you know atomic number equals to number of protons, that means 50. What is the mass number? Mass number equals to the sum of number of protons plus neutrons. That means your mass number equals to 122. What is the charge of this atom? When you calculate the charge, you have to sum up the negative charges plus the positive charges. So you have 48 electrons, that means you have -48, and you have 50 protons, that means you have +50. Sum of these two numbers equals to +2. This is the charge of your atom. What is the isotope symbol of this atom? If you say your atom is A, you are going to write it down as 50 in the bottom, that is your atomic number, and 122 in the top, that is your mass number. And if you go to your periodic table, you will find 50. That means it is tin. So you can, what is the name of this isotope? You can call it tin 122. A 25 gram sample of limestone calcium carbonate is heated, forming 14 grams of quicklime calcium oxide and a gas. How many grams of gas should have formed? Which law is your answer based on? At this point, you don't have to know the formulas of calcium carbonate, calcium oxide, or the gas formed, which is carbon dioxide. However, let's look at this extra information. This will benefit your further studies. Molar mass of calcium carbonate equals to 100 grams and the molar mass of calcium oxide equals to 56 grams. That means if we heat 100 grams of calcium carbonate, you are going to end up with 56 grams of calcium oxide plus the gas. So the question is about 25 grams of sample. So let's say we divide this equation by 4. And you are going to have 25 grams of your sample and you are going to heat it and you are going to get 14 grams of quicklime and some amount of gas. So to find the amount of gas, we are going to subtract 14 by 25. That means the mass of grams equals to 11. So the law you are going to use here is law of conservation of matter. Complete the following table. You are given 4 atoms and some data about protons, neutrons, electrons, mass number and charge. Now you know the mass number is protons plus neutrons and the charge is the sum of your negative and positive in the nucleus. So mass number in atom A is proton plus neutrons. That means 32. The charge is you have 15 protons and 16 electrons. The difference of these two is -1. For the atom B, you have 26 protons and 23 electrons and its mass number is 56. To find the number of neutrons, you are going to subtract number of protons by your mass number. That means 30. To find the charge, you are going to sum up your negative values. That means -23 and your positive values. That means +26. The difference is +3. So in atom C, you have given the number of neutrons, mass number and the charge. To find the protons, you are going to subtract your neutrons by your mass number. That means 77. The electrons are, if you have the charges given, that means your charge is equal to number of electrons plus number of protons. By this equation, you can find the number of electrons are equal to 73. In atom D, you have given the number of protons, mass number and the charge. Now you have to find the number of neutrons. So you are going to subtract your number of protons by your mass number. That means 74 is equal to number of neutrons. To find the number of electrons, you are going to use the same equation. Your charge equals to number of electrons plus number of protons. So you will see your number of electrons equal to 53. How many protons and neutrons are in each of the following isotopes? Now you know the mass number equals to number of protons plus number of neutrons. Atomic number equals to number of protons. For beryllium, you have 4 protons and then you take 10, that is your mass number, and the mass number equals to 4 plus number of neutrons, that makes 6. Argon has 18 protons and then 22 neutrons. Nickel has 28 protons and 34 neutrons. Silver has 47 protons and 62 neutrons. Mercury has 80 protons and 119 neutrons. Magnesium has 3 naturally occurring isotopes. Use following information to verify the element's atomic mass of 24.31. So you should know that the atomic mass equal to the weighted average of these isotopes. To find the weighted average of the isotopes, we are going to take each isotope one by one and then take the mass and multiply it by the percent abundance as a fraction and add them together. So the first isotope is 23.99 in mass and then its percent abundance is 78.99, and it as a fraction we are going to multiply this mass by 0.7899, and we do the same thing to this isotope and this isotope, and then we are going to add these 3 values together. And when you do that, you can see the atomic mass equals to 24.31. Match each element with its appropriate classification. So let's go to the periodic table. The elements in group 1A except hydrogen are called alkali metals. The elements in group 2A are called alkaline earth metals, and then you have your transition metals and inner transition metals. These are called the elements in P block, and the elements in 7A are called halogens and elements in 8A are called noble gases. The elements in S block and P block are called main group elements. And then you have diatomic elements in your 6A and 7A. Let's take aluminum, and it is a main group element and an monatomic element. Chlorine is a halogen, main group element and diatomic element. Iron is a transition element and a monatomic element. Lead is a main group element and monatomic element. Magnesium is alkaline earth metal and a main group element and a monatomic element. Neon is a noble gas, main group element and a monatomic element. Oxygen is a main group element plus a diatomic element. Uranium is an inner transition element and a monatomic element. Copper has two naturally occurring isotopes, copper 63 and copper 65. If copper 63 has a mass of 62.93 and a natural abundance of 69.17, what is the mass and percent abundance of copper 65? Copper has an atomic mass of 63.55. Now you know the atomic mass is equal to the weighted average of the isotopes. Let's look at the data given. You have two isotopes, and for one isotope the mass and the percent abundance are given. So this is the mass we are going to find, and you can find the percent abundance of copper 65 by subtracting 69.17 by 100. That makes 30.83%. Let's do the weighted averages. We are going to take this mass and the percent abundance as a fraction, and then we are going to add to this mass, which is we don't know yet, and then the percent abundance, and this equals to 63.55. By solving this, you will see that the mass of copper 65 is 64.93. An isotope is found to be 4.6613 times heavier than that of carbon-12. Calculate the mass of this isotope. If its percent abundance is high, what is the possible identity of this isotope? So the mass of carbon-12 is, to get that, you go to your periodic table and get the mass number. It is 12.01 atomic mass units. Now we are going to multiply by 4.6613 and it will make the mass of your atom to be 55.98. Again, you are going to the periodic table and find which one has the 56 atomic mass units, and it turns out to be iron. Gallium has two stable isotopes, gallium-69 and gallium-71. The masses of these two isotopes are 68.93 and 70.92. Use these masses along with gallium's atomic weight 69.73 to calculate the percent abundance of each isotope. So we have given two isotopes, 69 and 71, and we have given the masses 68.93 and 70.92. What we need to find are the percent abundance. So we are going to say the percent abundance of gallium-69 is X. That makes the percent abundance of gallium-71 to be 1 minus X. Now we are going to do the equation for the weighted averages. We take the mass and times X, and we are going to sum this weighted average. We are going to take 70.92 times 1 minus X, and this equal to your atomic mass, which is 69.73. By solving this equation, you will see the x is equal to 0.598 and 1 minus x is equal to 0.402. That makes the percentages to be gallium 69 59.8 and then gallium 71 40.2. This is the end of this presentation, and please let me know if you have any questions. Thank you.